assume it.
We do the science for you.
I'm following the assumption that organic agriculture is better for the soil ecology, and more specifically, soil bacteria. Soil bacteria have an important role in agriculture because of their influence on nutrients as well as soil health. Bacteria in the soil have several functions. The majority of them are decomposers that feed on simple carbon compounds, such as root exudates and plant litter. Bacteria that are mutualists often provide agriculture nitrogen sources for plants. Soil bacteria are a lot more abundant than other soil microorganisms. In a teaspoon, there are 100 million to a billion soil bacteria cells. Because soil bacteria can help stabilize soil aggregates, they help with water dynamics within the soil profile. Additionally, some bacteria can outcompete disease-causing organisms within the soil profile. Bacteria are very important in the nutrient cycling because they are able to immobilize nitrogen and prevent the loss of the nutrient. I went back to Colorado State University, where I could talk with my former soil microbiology teacher, Dr. Mary Stromberger. She explained to me about one of her graduate students currently doing work in the field about organic agriculture and the soil food web.
And you hear, word of mouth. You hear it in popular press, radio, stories. And so, but when we actually sat down and it was time for her to write her thesis and then that chapter and convert it into a publication, that's when we realized that there really isn't a lot of scientific evidence, and I was shocked. I couldn't believe it. Because you hear people say that all the time. So now I'm actually very excited about her research because there really isn't a lot of data out there, scientific information and experiment. Hopefully that makes you feel better.
Oh yeah,
being
definitely.
able to find papers, because I haven't been able to find a lot of papers.
With my hopes not too high, I sought out to find as many journals as possible on the topic. Peer-reviewed journals. Researchers at the University of Wyoming did a 4-year study in which they found organic and reduced tilled systems promoted higher microbial communities. They attributed this to the use of perennial legumes as well as organic amendments. Swiss researchers did a very long-term 20-year study in which they used pyrosequencing in order to graph out DNA. They found that species richness of soil bacteria increased in the organic systems. This colorful graph represents the different kinds of bacteria they pyrosequenced. Researchers in the UK did a comparative study in which they found that species richness increased in organic systems. However, they did find methodological issues when comparing studies and could not come up with a quantitative result. The Estonian Research Institute did a 5-year study on soil bacteria. They found that conventional organic systems using manure had higher bacterial communities than other systems. At Canada's longest organic conventional study plot, they found pH to be the driving factor in soil bacteria communities. Although the organic systems had higher species richness in soil bacteria, they were not significant. The proteobacteria preferred the organic soils, and they contain a lot of very beneficial bacteria. I was fortunate enough to have Cynthia Collenbach come to our Topics in Organic class and speak about soil microbiology. She's published multiple studies. One study was a meta-analysis in which she found that cow manure was heavily preferred by soil bacteria compared to inorganic fertilizers and other manure. She very recently published a study about cover crops and input quality She found that this input diversity heavily influenced microbial physiology. At North Carolina State, they did a 3-year study including 10 local farms that were organic, conventional, or sustainable. They found that the microbial responded better in the organic soils, as well as reducing southern blight significantly. They also found a greater diversity in the organic systems. Researchers at Pondicherry University found significantly higher soil bacteria in organic systems. However, the methodology was very short and very few soil replications were taken. Researchers at Wageningen University in the Netherlands looked at 20 farms very close in proximity with either organic or conventional management. They did a very in-depth farmer inquiry about what kind of management practices they used. They found that shallow plowing had heavy influence on microbial activity, benefiting organic systems. They also found pH to be a heavy driver. Let's head on back to Fort Collins so I can wrap my head around all this information. My critique would be that every journal pretty much stated that there's the need for long-term replicated studies. With all the studies being very recent, there is hope for the future. Additionally, the soil food web is very complex. You can try to measure soil bacteria, but because they are fed on by so many other microorganisms, it's hard to measure their exact biomass and biodiversity. Hopefully Dr. Stromberger can help me come to a conclusion.
Organic systems should do this because they are about reducing the use of chemicals that are harmful to soil organisms. So having less inorganic fertilizer and less pesticides would promote biological diversity. Tillage can benefit bacteria by mixing them with the soil, mixing them with water, mixing organic matter with bacteria, and you see a pulse of bacterial activity after tillage. The downside, though, is that long-term tillage, because it destroys aggregates and exposes protected organic matter, eventually organic matter levels will start to decline in soil, and that the declining soil organic matter will negatively impact bacteria.
Back to the assumption board. What's the final verdict? Scientific literature supports this assumption. Organic systems provide cover crops, manures, and other forms of organic amendments that are preferred by bacterial communities. Scientific literature shows this.